Hey, it's Dan. Let's look at a little geometry here. Consider this problem. And this is a problem that comes up in the math book where we're talking about the triangle mid-segment theorem. That triangle mid-segment theorem. And the idea is that, regardless of what the picture looks like, when you have these markings here, it says this side is congruent to that side, and this is congruent to that, and this is congruent to that. This is a triangle that's connected in its mid-segments. And one of the things we learn from this is that when it's a mid-segment here and a mid-segment here, is that this piece is half of the big piece here. These have to be parallel. These legs here have to be parallel. And so if this is 19, then this big side over here is 38. So that's one of the things. The other thing is that because these are parallel, this is parallel to this, that this acts as a transversal. So that's why X is 55 here. If this is 55, then this is 55, because those are alternate interior angles. Think about these as parallel lines with a transversal going through them, alternate interior angles. So X is 55. Notice also that Y is 55. Now these are corresponding angles. So think about parallel line, transversal going here. These are corresponding angles, so they're both 55. And then this Z has to be supplementary to this. So that's like same side interior angles. So if you have two parallel lines and a transversal here, then the two interior same side angles are going to be supplementary. So since Y is 55, Z has to be 125. So that's a little bit with angles. So when you're doing this, two times this short side is going to be the big side here, and half of this will be that. So there's different ways of thinking about it. A lot of times when you have a variable here and you're trying to find, what the variable is to make it equal to this, it's easier to say 2 times whatever this is equal to whatever this big side is over here. Anyway, so that's a little bit on the triangle mid-segment theorem.